You start?
Yes.
Okay, Shlab. So here we need to find the net force on this charge. dq. So Q and 2Q, they are both positive. Do they attract or do they repel each other?
They repel.
Repel. So we know that Q is trying to run away from the 2Q. So this is the force between Q and 2Q, like this.
Can you write the signs so we can know if it's attractive?
Yeah, look at it. Same sign. Q, 2Q, positive, positive. Now, Q and the other 2Q, do they attract or repel?
They also repel.
They also repel.
Teacher, we post in YouTube.
Inshallah. So force between Q and 2Q repelled and it's going upwards. Now, we need to find this force and that force, then we find the net force. So force between Q and 2Q is equal to the following. It's equal to K.
Q1.
What does the question say? Leave it in symbolic form. Use K as K, distance as A. So it's equal to K times the first charge, which is Q, times 2Q divided by the distance between them squared. What's the distance between them?
A.
A squared. Can we simplify this? Yes, we can.
Yes.
It would be 2 times K. Q times Q is equal to what?
Q square.
Q times Q. Q squared. As if you're multiplying X by X. Same thing.
No, 2Q squared.
Right, 2Q squared.
Q times 2Q.
No.
Q times 2Q. Q times 2Q is 2Q squared. Okay? Over the distance between them squared. What's the direction of this force?
55.
To the right.
East. وين الأرقام؟
To the right or east? Symbolic. No numbers. This is why. Now, the other force is Shabab, which is on the y-axis. Same thing. It will have the same magnitude. Force on the y-axis, it will be of the same magnitude. Because Q and 2Q. So, force of Q and 2Q, which is on the y-axis, let's say this is on X. This is on Y. Is equal to the same one, but the direction will be. What will be the direction? Upward. We're taking on this chart. Repel. So 2K Q squared over A squared, and the direction is up.
Teacher.
Now, let's find. Yes, Alhamdulillah. Bathroom.
Can you move that?
Now, net force on x-axis is equal to what, Shabab? It's equal to this value.
I'm good.
2K Q squared over A squared, and it's to the right or to the east. Newtons to the east. Newtons to the east.
Definite Y.
On the y-axis, net force on the y-axis is equal to 2K Q squared over A squared, and it is
North.
north. Newtons to the north.
Then we do of net.
We need to find net force. How do we find net force? We draw them. Let me turn off the projector.
The Pythagorean.
Thank you. So يا شباب, we do the following. Now let's draw them. So we have net force on X is to the right. F net X. Net force on Y is pointing up. And to find the resultant, we connect from the tail of the first one, or the starting point, to the ending point, and we put the arrow on the ending point. Let's call this as F net. So how do we find the net force?
The Pythagorean theorem.
Pythagorean theorem. So we say that net force is equal to square root of net force on x squared plus
F net Y squared.
net force on y squared. Let's replace it. What's the net force on x-axis? This one. So 2K
Q squared.
Q squared.
divided A squared.
over A squared, all of it
squared.
squared.
Same stuff.
Plus
Plus
2K.
same.
Yeah, so.
How do we?
which is equal to what? We do the following. You say that 2 squared, which is 4. Okay, let's do it step by step. So 4k squared q power 4 over a power 4 plus 4k squared q power 4 over a power 4. What do we do now? I have 4x and 4x, which will be 8x,
It's 4K and 4K.
which will be like this. So 8k squared q power 4 over a power 4.
Teacher, we have 2.
Properties of radicals. You can take out the variables and keep the numbers. So it would be equal to radical 8 times k
Plus times
q squared over s.
Teacher,
squared then.
Radical and squared. What's
But it doesn't cancel it.
the value of this?
X.
Yeah, but
teacher.
there's another value which you cannot cancel.
It's multiplied by it, not added. If it's added, you cannot take it out. If it's multiplied, you can.
Okay,
The
so
Q power 4, there are 2, so you
I
need 2
got
Q
you
power 4.
accept the last step.
No, I added all. So 4q power 4, 4q power 4. All of it. 8 times all of it.
بس انا كنت فاهم كل شيء اللي ناخذ ستيب.
Last step, okay. Again, يا شباب.
ما اعرف ليش بالعراق كيف.
So here, how do we add this, يا شباب? They have the same numerator. Do it step by step.
Denominator.
Same denominator, sorry. So you add 4k squared q power 4 plus 4k squared q power 4, which will be
8K Q.
8k squared q power 4 over the
A power.
denominator that they have in common. Then, what's radical k squared? K. What's radical q power 4? Q squared. What's radical a power 4?
الحين
K
ما
squared.
ليش طلع او سوينا كانسل السكوير اوكي.
Yes.
So we can simplify more or less.
Now, this is the magnitude in newtons. Now, let's find the angle. How do we find the angle? So the angle, ya Khalid, is equal to the following. Tan inverse
Y over X.
net force on y over net force on x,
يعني 2k
which is tan inverse of all of this. Now, 2k q squared over a squared, all of it divided by itself. 2k q squared over a squared.
يعني equals to
It's
1.
gonna become
As if you are
1.
dividing something by itself. X over x is
1.
1.
1.
Negative
so it's
1?
equal to tan inverse
1.
of 1, which is 45 degrees.
خلاص انا نقدر نحط 45 دقيقة.
From the positive x-axis, let's check the quadrant. So 1, 2, 3, 4. First quadrant, so we keep the angle as it is.
زين فهمت.
Stop. So it's saying the following. The figure below shows 3-point charges. All are positive. The net electric force on the center charge is 0. If I say that the net force is 0, what comes up to our mind? Equilibrium, yes. Equilibrium. What is the value of y over x? So they want us to find the ratio of distances. So, which charge has equilibrium, ya Khalid? This one.
Yes. Yes.
The one in the middle.
Q.
So, this is the charge plus Q. Now, look at this, ya Waris Khalid Hamadi, because you asked me about this. Are you there? Okay. Q and 3Q, do they attract or repel?
Repel.
I cannot hear you. Repel. Why do they repel and both are positive? So the direction of force between this and this is to that side. So this is the force between Q and the 3Q.
Teacher, if it was attract, it will go to the
It
right.
will go, yeah, towards it. And it's trying to go to it. Now, The force between Q and 2Q, do they attract or repel? Come on, repel. We are finding net force on the plus Q. So it will try to go away from the 2Q. So let's call this as the force between Q and the 2Q. So now, we know that this force should be equal to this force. Why?
Because equilibrium.
Because of equilibrium, which means that net force is 0. So the net force on the right side should be equal to the net force on the left side. So we say that force of Q and 2Q is equal to the force between Q and 3Q, which is K. Q times 2Q over, what's the distance between Q and 2Q?
X plus Y.
So over x squared is equal to,
بس صار Q2 is Y. Because it is
that height between Q and 2Q, what's the distance?
Oh, we lost it down.
X.
Also good.
Okay? And the distance between, sorry, so K, Q times 3Q over, what's the distance between them?
Y is good.
Over Y, and it is squared. Now, ya shabab, look at this. So what is on both sides? Or before that, let's rewrite this in another form. So we'll have 2kq squared over x squared is equal to 3kq squared over y squared. What is something which is common on both sides?
KQ squared.
K and the Q squared. ليش يا بكر? Because we have K on this side and K on this side, Q squared here, Q squared there. Multiplied, you can cancel. If you were added to something, you cannot cancel. Keep this in mind. So now يا شباب, we have 2 over x squared is equal to 3 over y squared. We do cross multiplication. What does the cross multiplication say? If I put this arrow, it means that I can interchange the position of this and this. So we'll have the following. So it will be y squared over x squared is equal to 3 over 2. This is y squared over x squared. What do they want? Y over x. How do we get y over x?
Square root of both sides.
Square root of both sides. Which will give us at the end that y over x is equal to square root of 3 over 2.
We don't do plus minus. Plus minus.
Ratio, you don't need to do the plus or minus. And it's ratio. Ratio of distances.
Counter.
Like